Good day, everyone. So for today, we will be having another Module 13, here in Math 171, Differential Calculus or Calculus 1. Ang topic natin today is the differentiation of transcendental functions, trigonometric functions, and the application ng trigo function pagdating sa maxima and minima. Okay, so but before we discuss yung Module 13, let us first have the lesson objectives ng ating module. First is for us to be able to recall and state the trigonometric identities. So from the previous modules natin, especially sa trigonometry natin, we discussed trigonometric identities. So pagdating dito sa module natin today is i-refresh lang natin siya. And titingnan natin kung ano yung mga most common. Ipa-present natin yung most common identities na ginagamit sa differentiation. Next is for us to be able to state and derive the derivative of trigonometric function. So we have here sa ating module, meron kasing process, kumbaga kung paano na-solve or paano nag-come up dun sa formula. Kasi gagamit na lang tayo ng formula dito pag nagdi-differentiate tayo ng trigonometric functions. And lastly, find the derivative of trigonometric functions. So we will have examples later, mga problems wherein gagamitin natin yung formulas ng differentiation pagdating sa trigonometric functions. So as part of our learning objectives is i-recall natin sa module na to yung mga identities or trigonometric identities. So we have here three: Pythagorean identities, reciprocal identities or reciprocal relation, and quotient relation. So yung tatlo na to is na-present natin previously sa mga modules natin. And ito yung mga pinaka-ginagamit pagdating sa differentiation o sa pagkuha ng derivative ng functions. But at the same time, mahalaga din na kabisado nyo yung hindi nakalista dito sa tatlo na ito para at least kapag hindi nagpo-fall dito yung mga given problems, alam nyo pa rin sagutin. Okay? Same approach pa rin naman yung gagawin nyo when it comes to differentiation. Mag-iiba lang yung identities na gagamitin nyo. Anyway, sa Pythagorean identities, we have sine squared x cosine plus cosine x squared is equal to 1. Tangent squared x is plus 1 is equal to secant x squared. And cotangent x squared plus 1 is equal to cosecant x squared. And the reciprocal relation is yung common na sine, cosine, tangent. Yung sine natin is the reciprocal of cosecant x. Yung cosine x naman natin is the reciprocal niya na 1 over secant x. And then yung tangent, as you can see, 1 over secant x yan. Meron lang mali sa module, so itama lang natin. Pag sinabi nating tangent x, diba ang reciprocal niya is 1 over cotangent x. So siguro sa module nyo, nakopya lang yung nandito sa cosine x. And lastly, we have the quotient relation. Yung tangent x is just the fraction ng sine x and cosine x. Saka yung cotangent x is yung cosine x over sine x. So nirefresh lang natin yung ating identities or trigonometric identities. As I mentioned earlier sa ating lecture video, we have formulas na gagamitin natin pag nagdi-differentiate tayo ng trigonometric function. So actually sa module nyo, sa copy ng module nyo, merong derivation doon kung paano nag-come up dito sa inyong, dito sa ating anim na formulas na ito. So feel free na i-browse na lang yung module nyo kung paano nag-come up, pero hindi naman siya ganun kakailangan kapag nagsosolve sa problems. Okay, so gagamitin lang naman natin to directly. So for derivative of sine u, we have cosine u times derivative ng u in terms of x. So we have a derivative of cosine u naman is equal to negative sine u, derivative of u in terms of x. For tangent u, ang derivative niya is secant u squared times du over dx. And then yung cotangent u, ang derivative naman niya is equal to negative cosecant u squared du over dx. For secant u, ang derivative naman niya is secant u tangent u, derivative ng u over dx. And then lastly, for cosecant u, derivative niya is equal to negative cosecant u cotangent u times derivative of u in terms of x. So medyo madami. Okay? So, kabisaduhin nyo lang class yung formula natin. So, paano ba natin makakabisado yan? The only way na maibibigay kong advice para makabisado yan is to use them lagi sa pagsasolve ng problems. So, binigay naman na yung formula. So, I think kaya naman na natin gamitin yan. Pero I know hindi nyo pa alam siya gamitin for now. So, let's proceed to our examples para mas malaman natin kung paano siya ginagamit. So, dito sa ating example, first example, binigyan tayo ng function na y is equal to sine 5x or sine of 5x. So, isulat lang natin yung formula ng ating derivative pagdating sa sine. Okay, sabi kanina sa mga pinasent nating formula is that derivative of sine u in terms of x is just equal to cosine u derivative of u in terms of x. So we have your sine of 5 of x. So isulat lang natin sa formula natin, derivative of sine 5x. So first, identify nyo muna kung ano yung u sa given problem natin. So in this case, ang u natin ay equal sa 5x. Kung napapansin nyo, meron tayong du over dx. So kunin lang natin yung derivative ng u in terms of x. So ang derivative ng 5x is just equal to 5. Therefore, yung du over dx natin is equal to 5. So substitute natin yung value. You have cosine u, which is yung 5x. Tapos yung du over dx natin na 5. So sisimplify lang natin, yan ay 5 cosine 5x. So therefore, eto na yung ating sagot. Okay, so ganun lang natin gamitin yung formula ng differentiation pagdating sa trigonometric functions. So dito sa example number 2, we have y is equal to cosine 5x. So isulat mo natin yung formula pagdating sa differentiation ng cosine function. We have derivative of cosine u in terms of x is equal to negative sine u du over dx. Okay, so gaya ng ginawa natin kanina sa example number 1, let us first check kung ano ba yung u value natin. So in this case, ang ating u is 5x. So gaya ng ginawa kanina, kunin natin yung derivative of u in terms of x. So du over dx is equal to 5. So substitute ulit yung values, we will have negative sine. Tapos yung u natin is 5x times yung 5. So therefore, ang ating derivative of cosine 5x is just negative 5 sine of 5x. So ito na agad yung ating final answer. So we have here for example number 3, y is equal to tangent 5x. So ano ang formula ng derivative pagdating sa tangent? Yun ay derivative of tan u in terms of x is equal to secant squared u derivative of u in terms of x. So identify ulit kung ano yung u, yun yung 5x ulit. So du over dx is equal to 5. So ngayon, substituting the value, secant squared, tapos 5x, tapos yung derivative of 2 in terms of x is 5. Therefore, ang ating sagot is 5, secant squared 5x. For our example number 4, we have y is equal to cotangent 5x. So gamitin natin yung formula. Ano ba yung formula? Pinrasan kanina, yun yung derivative of cotangent u. Yun ay negative cosecant squared u. Tapos derivative of u in terms of x. Identifying u is equal to 5x and then derivative ng u in terms of x is just equal to 5. Okay, substitute nyo lang yung u ganun sa ginawa natin sa previous examples. So cosecant squared 5x. Tapos yung 5 na du over dx. Simplify, you have negative 5 cosecant squared of 5 of x. So for example number 5, we have y is equal to secant 5x. So ang derivative pagdating sa second function, secant u tangent u du over dx. Okay, so pag in-identify yung u, yun yung 5x, then get the derivative of 5x. Ito ay 5. So substituting the value, secant 5 of x, or 5x, then tangent 5x times 5. Therefore, ang ating derivative ay equal sa 5 secant 5x tangent 5x. So another example is yung 6. Number 6, y is equal to cosecant 5x. Ang u natin is 5x. Tapos ang formula natin sa derivative pag cosecant is negative cosecant u cotangent u du over dx. So ang du natin in terms of dx ay 5 ulit. negative cosecant 5x, cotangent 5x, and then times 5. Simplify, you have a negative 5, cosecant 5x, cotangent 5x. So ito na yung final answer natin. So class, mag-ingat lang kayo dun sa mga negative sign kasi hindi yan lahat positive. So kung babalikan natin yung solution natin, pag kinuha natin yung derivative ng sign, positive cosine siya. Pero pag kinuha natin yung derivative ng cosine, magiging negative sign yung ating sagot. Okay, so kapag dating naman doon sa second, positive, di ba? Pero sa cosecant is negative yung nagiging resulting niya after differentiation. So, bantayan niyo lang yung mga formulas niyo. Tapos yung sign. Anyway, let's proceed to another examples. Mas complex na example. So, dito pinresent lang natin paano gamitin yung kada derivative o kada differentiation formula pagdating sa trigonometric functions. So, we have here y is equal to sine 5x raised to 3. Okay, so dito nagkaroon na tayo ng exponent. So paano natin yan isa-solve para makuha yung dy over dx natin. So first, pwede kasi natin i-rewrite, di ba, yung sine 5x raised to 3 na ito in this form. Di ba? So po pwede natin gamitin dyan is chain rule. So yun yung mga nasa previous module natin. So kung gagamit tayo ng chain rule, yan ay magiging 3. Lalababa lang natin yung 3. Then sine 5x, then 3 minus 1, then get the derivative nung nasa loob na ito, yung sine 5x. So yan ay magiging cosine 5x. And then, kunin nyo yung derivative niya, yung 5x o yung u ng cosine, yan ay 5. So, simplify natin, 3 times 15, we have 15. Tapos, yung sine and cosine, simplify din natin, sine 5x raised to 2 times cosine 5x. So, pwede pa nating i-rewrite lang yan. 15 sine squared 5x cosine 5x. So, therefore, the derivative of our given function in terms of x is equal to 15 sine squared 5x times cosine 5x. So, kung napansin nyo, nandito kanina yung dy over dx, di ba? Binaba ko dito. Dito kasi yung start ng ating differentiation. So, ito kasi is yung function pa rin na given, then nire-write lang natin. So now let's proceed to our next example. We have tangent of 5x raised to 4 or tangent raised to 4 5x. So to get the derivative, pwede nating i-rewrite muna yung given function in this form. Okay, tapos mag-proceed tayo sa chain rule. So dy over dx is equal to yung 4, ibaba natin. Then tangent 5x raised to 4 minus 3. And then yung derivative ng tangent 5x, huwag nyo kakalimutan, yung ano, secant squared 5x. And then kunin nyo yung derivative ng 5x, which is 5. So ngayon, simplify your answer. You have 4 times 5, which is 20. And then tangent 5x raised to 3. So mali lang nasulat dito. Ito. 1 lang yan, class. 3 na ilagay ko yung sagot na mismo. No? Anyway, huwag nyo kalimutan tong secant squared 5x. Ayan. So simplify lang natin, nire-write lang natin. You have 20 tangent 5x raised to 3. Tapos yung second 5x raised to 2. So therefore, ito na yung ating final answer. So for our example number 9, we have y is equal to cosine 3x squared. So bago natin i-differentiate yan, baka kasi magkaroon lang ng confusion or baka nalilito pa rin. So as you can see, yung squared natin, dito nakalagay, hindi ba? Since wala namang grouping symbol kagaya nito, meaning yung 2 na ito na exponent is nag-a-act lang siya para kay 3x. So therefore, itong function, yung given function natin is pwede natin i-write into cosine 9x squared. So baka kasi akala nyo yung cosine 3x squared na given is equal sa cosine squared 3x. And at the same time, equal din siya sa cosine 3x na ito. So class, hindi siya equal. Okay? Hindi siya equal sa dalawa na yan. Anyway, baka kasi magkaroon ng cases sa quiz na ganun yung magawa nyo. Kaya na-mention ko. Proceed tayo sa ating differentiation. So, meron tayong y is equal to cosine 9x squared. So as usual, kagaya ng ginawa natin kanina, pwede tayong mag-let u dyan. No? Yung ile-let u natin is 9x squared. So derivative of u in terms of x is 18x. Okay? So pag nag-derivative tayo, derivative of u o of y is equal, in terms of x is equal to, yung derivative ng cosine is negative sine u. Ang u natin is 9x squared. Then yung du over dx natin, yung 18x. So pag sinimplify natin, we will have 18x sine 9x squared dy over dx. So, ayan na yung ating final answer. For example, number 10, yung letter A natin, we have y is equal to sine cube, quantity x cube plus 1. So, dito, medyo marami nang nakalagay. So, ano ang pwede natin gawin dyan? So, pwede natin ulit i-rewrite yung ating given function. So, sine x cube plus 1, tapos yung exponent niya na 3. So, kung gaya ng ginawa natin kanina, pwede tayo mag-chain rule. So, dy over dx is equal to yung exponent na 3 is ibababa natin. Then, kokopyahin natin itong nasa loob ng exponent. So, sine x cube plus 1. So, 3 minus 1. And then, kunin nyo yung derivative ng nasa loob ng exponent, which is cosine x cube plus 1. So, hindi pa tapos, kunin nyo yung nasa loob na quantity, yung derivative nun. Yun ay 3x squared. So, yung 1, 0 na lang. So, if i-simplify natin, we will have, ayan, may 3 tayo dito, meron pa tayong 3 sa kabila. So, yan ay 9. So, ano pang pwede natin makuha? Yung x squared, itabi natin. So, ngayon, ang nawawala na lang itong dalawa. So, yung sign natin is raised sa 2. Tapos, x cubed plus 1. And then, cosine x cubed plus 1. So therefore, ito yung ating final answer for derivative of y in terms of x. So for example number 10, letter B, y is equal to square root of 1 plus secant 3x. So dito meron tayong radical sign. So as usual, pag meron tayong radical sign, tapos kinukuha natin yung derivative, automatically, parang meron tayong formula na agad na, diba, y is equal to square root of u. So derivative of y in terms of u is just 1 over 2 square root of u times the derivative of u in terms of x. So, ganyan ginagawa natin. So, if that's the case, apply natin sa ating given function. So, y is equal to, yung u natin dito is yung 1 plus secant 3x. So, kunin naman natin yung derivative ng u natin na 1 plus secant 3x in terms of x. Yan ay equal sa, yung 1 is 0 na. Derivative of secant 3x is secant 3x tangent 3x, tapos derivative of 3 which is 3. So, du over dx is equal to 3 secant 3x tangent 3x. So, gamitin natin itong formula na to. So, ito ay dy over dx is equal to, so we have here 2, tapos yung u natin na 1 plus secant 3x. So ito yan plus, yan yan. Kain 2. Then 1, tapos multiply natin yung du over dx natin, which is ito, 3 secant 3x tangent 3x. Okay, so rewrite lang natin is equal to, itong 3 secant 3x tangent 3x, pwede nyo naman na ilagay sa taas yan. 2 square root of 1 plus secant 3x. So therefore, ang ating final answer is itong 3 secant 3x tangent 3x over 2 square root of 1 plus secant 3x. For our last example, so we have here sine y plus cosine x is equal to 1. So as you can see, we have x and y na naka-combination or magkasama. So, therefore, ang pwede natin gamitin dyan is implicit differentiation. So, paano natin i-implicit yan? So, ganito lang. So, first, get the derivative of sine y. So, derivative of sine function is cosine u, or in this case, is cosine y. Then, get the derivative of y, which is dy or yung y prime na lang gamitin natin. Y prime. Okay. So dito sa problem natin ay pinapahanap is y double prime or second derivative. So plus, yung derivative ng cosine x is negative sine u or negative sine x. Then derivative of x in terms of x is equal to 1. Is equal to 0. Okay? So ngayon, ihiwalay lang natin yung y prime. Magkakaroon ka ng cosine y, y prime is equal to, ito ay negative sine x. Pag nilipat mo sa kanan, magiging sine x tapos positive. So divide both sides by cosine y, you will have y prime is equal to sine x cosine y. Okay, baka naiisip nyo, sir, pwede ko na bang gawing tangent yan? Eh, magkaiba naman yung inyong angle x sa y. So, hindi po pwede. So, ano pwede natin gawin para makuha yung double prime? So, mag-proceed tayo sa quotient rule natin. So, y double prime or second derivative will be equal to yung cosine y na v, di ba u over v yan. Pag quotient rule natin is v du minus u dv over v squared. Okay? So, v squared yung cosine y, yan squared. Tapos yung v natin is cosine y, derivative ng sine x is cosine x times 1. Okay, yung 1 na yun galing doon sa x na yun. Minus sine x. Derivative of cosine y is negative sine y. Then yung derivative na y prime. Okay, so simplify lang natin. Pero actually yung y prime na to, palitan na lang natin ng sine x over cosine y. Substitute lang natin. So y double prime is equal to, so cosine y tas cosine x. So may negative ka dito, tas may minus sign ka dyan, yan ay magiging plus. Then yung y prime mo is sine x over cosine y times sine x times sine y over, kalipat ko lang yung equal sign. Tapos cosine squared y. So simplify lang natin yung result na nakuha natin. Cosine x, cosine y plus. So wala namang makakancel. Pero etong yan sa kayan, pag pinag-over mo, pwede maging tangent yan. Pero wag na lang natin gawin. So ito, saka ito is magiging sine squared pag pinag-multiply. So sine squared x. Tapos sine y over cosine y over cosine squared y. So simplify pa natin. Dito na lang sa part na to. Meron kang denominator dito, di ba, na cosine y. So get the LCD lang. So you will have a cosine y. Tapos cosine x. Yung cosine y mo ngayon is magiging squared plus sine squared x sine y over cosine squared y. So extremes and means natin, you will have cosine x cosine squared y plus sine squared x sine y over cosine cube y. So therefore, ito yung ating magiging final answer. Yan ay yung second derivative ng given function of sine y plus cosine x is equal to 1. So I hope clear yung paggamit ng ating formulas pagdating sa trigonometric identity, trigonometric function differentiation. Okay, so dito is bumalik lang tayo dun sa may mga na-present natin from the previous module sa calculus, which is yung chain rule, mga differentiation formulas natin, gaya ng quotient rule, ayan. So, ginamit natin dito sa module natin. So, next part ng ating module 13, we have the application of maxima and minima involving trigo functions. So, binigyan tayo dito ng first example. We have here a circle, tapos merong rectangle sa loob niya. Sabi, find the shape of the rectangle of maximum parameter inscribed in a circle. So dito, meron yan illustration. So pwede natin i-adapt yung steps in solving maximum and minimum value sa previous module natin. Ano? So first step natin, syempre, is kailangan nating alamin kung ano ba yung unknown. So tinatanong dito yung shape ng rectangle. So merong rectangle sa loob ng circle. So as you can see sa ating illustration. Sir, rectangle. So, hindi natin pwede agad isagot yung rectangle na shape ng rectangle. Ano? So, pwede kasing maging square din yung rectangle sa loob ng ating circle. Since square is considered as rectangle, but rectangle cannot be considered as a square. So, pwede din ganun, di ba? So, meaning, hindi natin pwedeng isagot yung rectangle kabot. Kailangan natin ng solution. Next is to determine natin kung ano yung mga given quantities. So, as you can see, wala naman masyadong binigay na values. Pero binigyan tayo ng mga variables. Okay, na diameter or diagonal ng mismong square or diagonal ng mismong rectangle, and at the same time, yun din yung diameter ng ating circle. Binigyan din tayo ng theta wherein it is the angle between the diameter and sides of our rectangle sa loob ng circle. Binigyan din tayo ng x and y, which is the dimension of the rectangle. And then, determine the given condition. So, nagbanggit dito na maximum perimeter daw. Ano daw yung shape ng rectangle given na maximum perimeter yung nasa loob ng circle. Next is draw the figure. Meron naman na tayong illustration. Then, nag-set na tayo ng variables. Third step is to identify kung ano nga yung mga i-maximize and minimize na quantity. In this problem, the perimeter. Okay, so mag-set up muna tayo ng mga equations natin based sa ating illustration and based sa ating problem. So since perimeter ang pinapa-maximize, sige, kuha tayo ng equation based sa perimeter ng ating rectangle sa loob ng circle. So perimeter ng rectangle can be solved using the formula P is equal to 2x plus 2y. So yung x natin is ito, saka yung x dito sa taas, and then y, saka yung y sa kabila. Okay, so meron na tayong first equation. Ngayon, determine natin kung ano ba yung value ng x, ano yung value ng y. Paano ba natin siya makukuha? So pwede nating ihiwalay yung triangle natin na na-form. So meron tayong theta dito. Kasi ito yung d, ito yung y, and then ito yung x. So actually class, habang nagbabago kasi yung theta natin na ito, nagbabago din yung x saka yung y natin nagbabago. Ibig sabihin, pag masyado mahaba na yung x, liliit na yung theta natin based sa ating illustration. So naisingit ko lang din, meaning variable natin talaga, yung hindi constant value is yung theta saka x and y. Wherein yung x and y dependent sa theta. Okay. So kunin natin yung value ng x using trigo functions. Ano? So ito, tapos ayan. So therefore, pwede natin gamitin is cosine theta is equal to x over d, wherein x is equal to d cosine theta. And for y naman is sine theta is equal to y over d, or yung y is equal to d sine theta. Okay? So ngayon, sineset up kasi natin yung equation, tas dapat yung quantity na i-maximize or minimize natin naka in terms of one variable lang sana para mas madali siyang i-analyze. So P is equal to yung 2, substitute natin yung x, d cosine theta, plus 2 d sine theta. Yung d sine theta is yung ating y. So nagkaroon tayo ng P is equal to 2d cosine theta plus 2d sine theta. So yung d is constant. Kahit magbago yung theta and x and y natin, d pa rin yan, hindi yan lalaki, hindi liliit. Since diameter siya ng circle and at the same time, diagonal siya ng rectangle. Meaning constant siya. Well, in this case, yung p natin yung i-maximize and naka in terms of one variable na lang yung ating equation, which is yung theta. Okay? Yan, theta na lang yung variable sa ating equation. So ngayon, meron na tayong working equation. Ngayon, since ang i-maximize is perimeter, kunin natin yung derivative ng P or perimeter in terms of theta. Derivative of P in terms of theta is equal to 2D na constant. Derivative ng cosine theta is negative sine theta. Plus 2D. Tapos derivative ng sine theta is cosine theta. Since sabi natin kanina, and sa mga previous module, kapag maximum and minimum value sa isang function, ito ay equal to 0 ang first derivative. Ayan. So ngayon magkakaroon ka ng negative 2d sin theta plus 2d cosine theta. So ilipat ko lang sa kabila yung negative 2d sin theta. Magkakaroon ka ng 2d cosine theta is equal to 2d sin theta. So cancel na natin yung 2d both sides. Magkakaroon ka ng cosine theta is equal to sin theta. Sige. Ngayon, divide both sides by cosine na lang. Sige. Cosine theta. You will have 1 is equal to sine theta over cosine theta or tangent theta. Then kunin natin yung value ng theta. Paano? Arctangent. So arctangent of 1 is equal to 45 degrees. So yan, meron tayong value ng theta. Na-consider na rin natin yung maximized na perimeter. Ano nang next natin gawin? Balik tayo sa ating dalawang equation. Equation 1 and equation 2. So substitute natin yung value ng theta doon. Yung ating x is magiging equal sa d cosine 45 is equal to 0.707 d. Tapos, yung y naman natin is d sine 45 degrees will be equal to 0.707. And as you can see, yung value ng x and value ng y ay equal. Therefore, we could conclude that the shape of the rectangle is square. Okay? Kasi equal yung x and y. Since yung sides ang nagdidikta sa isang shape, kung anong shape siya. Okay? It's either shape is determined based on number of sides and based on the length of its sides. So anyway, dito sa ating problem, na-prove naman natin na square siya. Ayan. So I hope clear yung ating process paano natin na-solve yung problem natin. So it's more of like analysis talaga. And then imagination kung ano yung magbabago kapag nagbago yung isang value natin. Okay, so we have here example number 2. A cylinder is inscribed in a given sphere. Pag sinabing inscribed, is nakapaloob siya. So meaning nasa loob ng sphere yung cylinder na binigay sa atin. Find the shape of the cylinder if the convex surface area is a maximum. So hinahanap din ulit yung shape ng ating cylinder. So somehow, parehas lang siya ng approach na gagawin natin sa previous problem natin sa module na ito. Okay? So, ang pinapa-maximized is yung convex surface area. Okay? So, gaya nung steps na pinresent sa previous module, yung mga what is unknown. So, dito sa problem natin, ang unknown natin dito is yung shape. Okay? So, meaning, kailangan ulit nating hanapin yung dimensions ng cylinder para masabi ko anong shape yung cylinder na pinapa-analyze natin. So next, ano yung given quantities? Binigyan lang tayo ng variables. Meron tayo dyan theta, d, o yung diameter ng mismong sphere natin. H, yung height ng ating cylinder. May maliit na d, which is the diameter of the cylinder. Next is meron na tayong illustration. Tapos nakalagay na rin yung variables natin. Next step sa pag-analyze ng worded problems involving yung maxima and minima is yung ano nga ba, i-determine natin ano yung i-maximize or minimize natin. Well, in this case, in this example, yung convex surface area ang i-maximize natin. Sir, ano yung convex surface area? So, ito yung, ito diba, itong portion na yan is nakapa-curve yan. Kumbaga, titingnan mo sa taas, top view, ito yung face, ito yung taas. Ayan, yan. Kung titingin ka nyo sa taas, ito yun. And then yung surface area dito sa paligid ng mismong, ayan, yan ang convex surface area. Kumbaga, kukunin nyo yung surface area ng gilid ng cylinder. Hindi kasama yung top and bottom area. Okay? So, yun yung i-maximize natin. And then, magsiset tayo ng equation wherein yung units or yung variables natin is uniform. Okay? So, kumbaga, iisa lang yung variable natin sa ating equation. Okay? So, as you can see, dun sa ating figure, yung D and H is magbabago once magbago yung theta natin. Okay? So pag and then yung parang yung H and D is dependent sa theta. And at the same time, yung theta is dependent din sa H and D. Okay? So parang ganun sa example natin. Example number 1. Okay, so first is kunin natin yung formula ng convex surface area which is A is equal to 2 pi r h. But in this case, wala namang binigay na r or variable r dito sa ating figure. Therefore, yung r natin is gawin na lang nating diameter. Okay? Yun yung d na yun. So magiging A is equal to, yung d na maliit plus ha, magiging 2 pi, yung r natin is b over 2, hindi ba? Times h. Since may 2 ka dyan, may 2 ka dyan. Oh. A natin is pi d h. Yan yung convex surface area ng ating cylinder. So as you can see dito sa ating illustration, meron tayong d, meron tayong h, saka d na maliit and theta. So yung mga variables na yan, at saka yung illustration, pag tinignan natin sa side view, meron tayong mapoform na right triangle. And itong hypotenuse niya is yung malaking d, the diameter of the sphere. Yung d na maliit is yung diameter ng cylinder. And then we have theta. And then we have h. So syempre, pwede natin gamitin dyan is itong h, saka yung d, saka yung theta. O kung yan yung gagamitin natin, magkakaroon tayo ng sine theta is equal to h over d. And therefore, h is equal to d sine theta. And then para naman sa d natin, gamit tayo ng cosine, theta is equal to d over d. Ang d natin ay d cosine theta. So now, meron tayo values ng h na and d wherein parehas sila ng variable, which is theta. So yung d po ba is hindi variable? Hindi siya variable. Constant siya. Bakit? Kasi kahit anong value ng theta natin, kahit anong value ng h and d, constant yung d na ito. Hindi magbabago yan. Ganyan pa rin yung length niya. Anyway, i-plug in natin dito sa ating formula. A is equal to pi. Tapos yung d natin is d cosine theta. And h is d sine theta. Okay? So simplify lang natin, magkakaroon tayo ng pi d squared sine theta cosine theta. Since ipinapamaximize natin yung surface area which is yung A, therefore yan yung i-differentiate natin. So derivative of A, and since uniform na ang ating variable sa right side ng ating equation, naka in terms of theta na ang ating differentiation. Constant ang pi d squared, so itabi na lang natin siya. Okay, ang i-differentiate natin yung sine theta, cosine theta. Since yan is pwede natin gawing u, tapos b, proceed tayo sa product rule. So sine theta, ito yung u, derivative of cosine theta is negative sine theta. Plus cosine theta, derivative of sine theta is cosine theta. Okay, simplify, we will have a pi d squared, so cosine squared theta minus sine squared theta. So we have dA or derivative of A in terms of theta. Since maximum ang hinahanap natin, i-equate natin yung dA over d theta sa 0. Okay? So divide both sides by pi d squared. So magkakaroon ka ng cosine squared theta minus sine squared theta. So to 0. And then lipat natin yung sine theta o yung sine squared theta sa kabila. You will have a cosine squared theta is equal to sine squared theta. So divide both sides by cosine squared theta. Magkakaroon tayo ng 1 is equal to tangent squared theta. Okay, so get the square root of both sides. Magkakaroon tayo ng tangent theta is equal to 1. And then arctangent. Arctangent of 1 is equal to 45 degrees. Therefore, yung theta na ito yung value wherein maximum yung makukuha nating convex surface area pagdating sa cylinder. O, ano na next natin gawin? Proceed tayo sa nakuha nating equation 1 saka equation 2. Anong gagawin natin sa dalawa na yun? Substitute natin yung theta sa kanila para makuha yung h saka d, since yung h and d ang magsasabi kung anong shape of cylinder ang lumabas. Anyway, d times sine 45 degrees, and then d is equal to d cosine 45 degrees. So, pag kinalculate natin yan, h will be equal to 0.707, d and for D is equal to 0.707 D. So as you can see, H is equal to D. Therefore, the diameter ng ating yung diameter ng ating cylinder is equal lang din sa height ng ating cylinder. Okay? So kailangan equal silang dalawa para maximum yung makuha natin na convex surface area. So I hope clear yung ating module 13. Kailangan lang natin dito is kabisaduhin ang ating differentiation formulas pagdating sa trigonometric function. So actually, ito example 1 and 2 is kumbaga na-discuss naman na natin from previous modules. Sinamahan lang natin ang concept ng differentiation of trigo functions. Okay? So if you have questions and clarification with regard sa module 13, kindly raise your concerns in our group chats. And kung meron mali na isulat or meron kayong naguguluhan na part sa ating solutions, you may raise your questions sa ating communication platforms. Well, anyway, thank you for watching and listening to our lecture video for today.